Going to be a tutorial on rational functions. The first thing we need to know for rational functions is about the parent function. The parent function is f of x equals 1 over x. Using this parent function, you will get a graph that looks something like this. This is called a hyperbola. So whenever you have a parent function of f of x equals 1 over x, you will get a hyperbola as your graph. So hyperbolas. Hyperbolas are made from the reciprocal function, which is f of x equals 1 over x. This is also the parent function, but it's also the reciprocal function. It's the most basic form of it. So a hyperbola will look like we drew before. This is just a rough sketch, so this isn't exact, but it will have two curves that will continue going to infinity. Now, the easiest way to remember what a hyperbola looks like is to imagine that it's two parabolas that are kind of being mirrored over one another. So this would be one parabola, this would be another, and they're being reflected across this line. And that would be easiest to see. This is just a sketch, but in an actual drawing, they would match up perfectly and be the same parabola, so to speak, but they're a hyperbola. So rational functions. Right here is the form of the rational function that we will be using to find everything else and evaluating it. So this form is f of x equals a times x plus b over c times x plus d. Now, make sure you have this in your notes. We will be coming back to it. We will need it. Also, make sure that you have the hyperbola notes from before, because this function will also give us a hyperbola because it is just an extension of the parent function. So next thing that we need to learn about are the asymptotes. Asymptotes are the number that the graph will approach, but it won't ever cross. So on this graph down here, we have a hyperbola with the two curves, and the asymptotes would be these dotted lines right here. So right here is the vertical asymptote and the horizontal asymptote. Now these curves right here, they will approach the asymptote for pretty much infinity. They'll just keep going, keep approaching it till you won't even be able to see. They'll be that close. But they will never touch or cross the asymptote. So if this dotted line is the asymptote, the hyperbola will never go like this. It will never do that. That will never happen. It will approach it for infinity, but it will never cross it. That is very important to remember. So every graph of a hyperbola has two asymptotes. There's the vertical asymptote and the horizontal asymptote. The vertical asymptote can be found when the denominator equals 0. So the denominator cannot equal 0 because dividing by 0 makes the function undefined. So the asymptotes are a line that the hyperbola never touches, so that is the undefined line. So the denominator equaling 0 would be the vertical asymptote. The horizontal asymptote is a bit trickier to find. It is when you divide the coefficients of x. So dividing the coefficients of x, if you had 4x plus 6 over 2x minus 3, you would do 4x over 2x ends up equaling 2, and that would be your horizontal asymptote. So here is f of x equals 2x plus 3 over x minus 2. We're going to find both the vertical and the horizontal asymptote. So to find the vertical asymptote, we do the denominator set equal to 0. So x minus 2 equals 0. And then we add 2 to both sides to get x equals 2. So your vertical asymptote is going to be 2. Your horizontal asymptote, we look at our coefficients of x, which are right here. So we have 2x over x, and that would equal 2. So our horizontal asymptote is 2. Now if we're going to write these as an equation, because asymptotes are lines, our vertical asymptote would be x equals 2, and our horizontal asymptote would be y equals 2, because having y equal number gives you a horizontal line, and having x equal number gives you a vertical line. So if I were to draw a quick little rough sketch over here in this corner, we'll erase this. Make sure you have this in your notes. So if I were to just draw a quick sketch over here of the asymptotes, so the vertical asymptote is 2, which x equals 2. So we find x equals 2. We just draw dashed lines for horizontal. So all asymptotes that you draw are going to be represented as dotted lines or dashed lines, just so you know that they are an asymptote and not the actual graph itself. So this right here is the vertical asymptote, x equals 2, and our horizontal asymptote is also 2, so we're going to find y equals 2, and we're going to have this. So these two right here are your vertical and horizontal asymptotes. So now we have to figure out how to find the y-intercept. So to find the y-intercept, you're going to substitute 0 in for all x's in the function. For example, if we had f of x equals 2x plus 3 over x minus 2. This would equal, if we plug 0 in, over 0 minus 2. So now 2 times 0 is 0, and then obviously 0. So we're going to have 3 over negative 2, which also is negative 3 halves. So our y-intercept is going to be negative 3 halves. But if we were going to write this as a point, it would be 0, comma, negative 3 over 2. So now we're going to find the x-intercept. To find the x-intercept, you set the numerator equal to 0. So once again, we'll have fx equals 2x plus 3 over x minus 2. So we'll take the numerator here. So we'll have 2x plus 3 equals 0. So we're going to subtract 3 from both sides. We'll have 2x equals negative 3. We will divide both sides by 2 to get x equals negative 3 halves. So in this case, our x-intercept and y-intercept are the same. That will not always happen, but there are different points because if you were to write this as a point, it would be negative 3 over 2, comma 0. Meanwhile, our y-intercept was 0, comma negative 3 halves. This one is negative 3 halves, comma 0 because it's along the x-axis instead of the y-axis. So now this is a problem that I want you guys to find the vertical asymptote, horizontal asymptote, y-intercept, and x-intercept for. So fx equals 4x minus 12 over x minus 1. So take the second to pause the video here. Starting. So now just take a second, pause the video for as long as it takes you to do this, and then just film it on and we'll have the answers. Okay, so I hope you have your answers. Right now we're going to go through and check them. So to find the vertical asymptote, we use the denominator, and we set the denominator equal to 0. So x minus 1 equals 0. We add 1 to both sides. X equals 1. So our vertical asymptote is 1. Our horizontal asymptote, we divide the coefficients. So 4x over x equals, if we do the math, it will equal 4. Our horizontal asymptote is 4. Our y-intercept, we substitute 0 in for all the x's in the function. So we're going to have 4 times 0 minus 12 over 0 minus 1. This gives us negative 12 over negative 1, or just 12. So our y-intercept is going to be 12. If we wrote it as a point, it would be 0, 12 up here, goes to this. Our x-intercept is when we set the numerator equal to 0. So 4x minus 12 equals 0. Add 12 to both sides. Just gonna do a little arrow. We'll do it over here. 4x equals 12. Now divide both sides by 4 so that we can get x alone. And x is going to equal 3. So our x-intercept is going to be 3. Or written as a point, it would be 3, 0. So check your answers. Make sure you got them right. Make sure you have all the work right too, because your answers are only half of the work. Make sure you have everything right. Copy this down in your notes, and we'll move on. The next thing we'll need to know about is domain and range. So make sure you write down these definitions in your notes for domain and range. The domain is the x values at which a function is defined, or simpler, it's so any x values that can be put into the function to get a real y value. The range is possible y values that would be the result of substituting in values for x. So, in other words, any real y values that you get by substituting the x values. So make sure you have these in your notes so you have them and can remember them. When talking about domain and range, it's easiest to think about it like this. So here's the graph of a hyperbola. Now this is just a rough sketch, so it's not going to look perfect. But right here, the arrows at the ends of the curve mean that the curve will continue. So arrows mean that this curve continues, and since we know that the curve continues to infinity, the answer to the domain and range could be any real number, because we know that the domain affects the x numbers. So if we go this way, there's always going to be an x number to satisfy it, except for the asymptotes. We know that the asymptotes do not count. So if we go up or down, there's always going to be a y value for the range to satisfy it. except once again for the asymptote, which we'll be talking about next. So really, the answer could be any real number. But then you might be wondering, well, how do we write the domain and range? Well, that's where the asymptotes come in. So our domain and range can be any real numbers except for the asymptotes. So if our vertical asymptote is x equals 1 and our horizontal asymptote is y equals 3, then that would leave us with our domain and range, which we need to know that domain is the x values. It deals with the x values right here. So since our vertical asymptote will always give us x equals something, our domain goes with our vertical asymptote. And our range is all the y values, and since our horizontal asymptote is y equals something, we're going to have our range is always going to be with the horizontal asymptote. So in this case, our vertical asymptote is x equals 1, and our domain that would leave our domain to be x such that x cannot equal 1, because x can be any number except for the asymptote, so x cannot equal 1. And now when we write our domain and range, we're always going to have these brackets at the end that kind of sections it off so that we know this is our domain and this is our range. This little line here means such that, so x such that x cannot equal 1. So we're always going to have this line meaning that such that x cannot equal. Now for our range, we're going to have these brackets again, but we're going to have y such that y cannot equal 0. Or, sorry, y cannot equal 3. Over here, x cannot equal 1 and y cannot equal 3 because our horizontal asymptote is y equals 3. So our domain is x such that x cannot equal 1 and y such that y cannot equal 1. To find the domain and range, just remember that we use our vertical asymptote and horizontal asymptote. Make sure that this is in your notes. So another thing we need to know is how to make a transformation of the reciprocal function. So this is this function that we start out with. F of x equals a times x minus b over c times x minus d. Now we want to transform that to get it into the form of y equals k plus a over x minus h. To do that, we're going to start with this form right here, and we're going to end with this form right here. We're going to use division along the way right here. To see this process, it's easiest if you follow along to an example. So here we have fx equals 2 times x plus 3 over x minus 2. To start, we're going to do division. Because 2x plus 3 is being divided by x minus 2, we're going to put 2x plus 3 in the little garage, if you want to call it, and then x minus 2 on the outside. So now x goes into 2x twice. So now we're going to multiply this by 2 to get it to go in here twice. So 2x multiplied by 2, negative 2 times 2 is negative 4. Then we subtract this, just like normal division. So 2x minus 2x leaves us a 0, and 3 minus a negative 4 gives us 7. So this is 0 plus 7, which is just 7. So now we have 2, because it goes there 2 full times, with a remainder of 7 times. So up here I'm just going to put remainder 7, just to remember that. And then, so remember that we have to get from this form to this form, y equals k plus a over x minus h. So now we have this division we did, leaves us with 2 with a remainder of 7. So this 2 is going to be our k value. So we're going to have y equals k, which is 2, plus the remainder 7 is going to be our a value. So 7 over, and then x minus h, we're going to keep the same denominator from up here. So whatever your denominator is when you start, you're going to keep that same denominator. That will also allow you to keep the same horizontal asymptote as well. Or vertical asymptote, I'm sorry, that's my mistake, vertical asymptote as well. You should be able to catch that because we know that vertical asymptotes are the denominator. So here we have what we started out with, which is fx equals 2x plus 3 over x minus 2. We brought that to become this form down here. I'll make it super dark so we can actually see where this is going. So that was transformed into y equals 2 plus 7 over x minus 2. Now right here you can see that the denominators stayed the same. The remainder from what we divided became the numerator, right here. And this 2 gets added on to the equation. It does not get multiplied or divided like anything that's happening here. It gets added on. So we went from fx equals 2x plus 3 over x minus 2 to y equals 2 plus 7 over x minus 2. This is a transformation of the reciprocal function. So at this time, please pause the video and write the transformation of this reciprocal function right here. When you have found the transformation, feel free to unpause the video and follow along for the answer. So first we start with division. So 3x plus 2 divided by x minus 1. X minus 1 goes in 3x plus 2 3 times with the remainder of 5, which is shown here. So now we put 3, y equals 3, plus 5, which is our remainder, over x minus 1, which is our original denominator. So y equals 3 plus 5 over x minus 1 is the transformation of the reciprocal function for this. Now we're going to focus on graphing. So right here is the problem we're going to graph. So fx equals 3x minus 2 over x minus 1. And yes, this is the same problem that we've been using for most of the different examples we've been going through, but I wanted to be able to find like the vertical asymptote and all the asymptote intercepts and graph for one equation so we can see how it all relates. So we've already found the vertical asymptote, horizontal asymptote, y-intercept, and an x-intercept for this, which are listed here. So using the information we've already found, we must sketch a graph of this function onto this graph here. So to show how that would be done is coming up next. So to sketch the vertical asymptote, we look at it, x equals 1. So when x equals 1, we're going to put a dashed line right here. This is our vertical asymptote. Our horizontal asymptote is going to be horizontal, but y equals 3. Y equals 3 is going to be right here. I should actually extend this up one. So then we look at our y-intercept, which is 0 and comma -3/2. So -3/2 is going to be, if our y-intercept is going to be right about here. When you're sketching it, you always want to label them. So this is 0, -3/2. That's what this point right here is. I should probably do that in a different color. So this point right here is 0, -3/2. Now our x-intercept is -3/2, 0, which is right here. We're going to put a little point there. And we're going to label this one as well, which is -3/2, 0. It's always good to label your points so you know what you're going for. And these are asymptotes. This one is x equals 1, and then this one is y equals 3. So from here, using these points, we're going to draw the curve of our graph. Remember, the curve approaches these asymptotes, so we're going to go like this. It also approaches down here. And since there's also, the hyperbola has a second curve, which would be in this quadrant because it's like the mirror going on an angle, it'd be in this quadrant up here, so we're going to draw this curve. This equation is in the way. We'll get rid of that for this time being. The curve would go right like this. You just kind of mimic what this one looks like for up here. So now you've graphed your hyperbola. Please attempt to do this problem on your own in your notes. So pause the video so you can do that. There are 5 parts, A, B, C, D, and E. Do all 5 parts using the equation up here. And then resume the video when you have completed all 5 parts to see the answers and how to do it. So if you've had time to solve this, fx equals x minus 5 over x plus 6. The vertical asymptote is -6. We get that by doing x plus 6 equals 0. Subtracting 6, x equals -6. Our horizontal asymptote is 1 because x divided by x equals 1. 1x, you have to imagine there's a coefficient here. 1x divided by 1x equals 1. Our y-intercept is -5, 6 because if we plug in 0 to x, that's 0 minus 5 over 0 plus 6, which gives us -5, 6 as our y-intercept. Our x-intercept is 5. Oops, that is because if we set our numerator, which is x minus 5, equals 0, we will have x minus 5 equals 0. Add 5 to both sides, x equals 5. Letter E, or part E, was to sketch the graph. So here I have the graph. I sketched our little graph going by ones. I placed all of our points and asymptotes in different colors so they're easier to see. So right here's our horizontal asymptote of y equals 1, our vertical asymptote of x equals 6. Here's our y-intercept of 0 of -5, 6, which is up here. And here's our x-intercept of 5, 0, which is right here. So to draw these curves now of the hyperbola, we cross through the points and allow it to approach the asymptote but not touch it. So we're going to go, it's going to go down here and curve, just like this. And then we have to do the opposite to this quadrant over here. And since we're just sketching the graph, we'll draw it in just like that. So this is an appropriate sketch of your graph. Make sure you have your points and asymptotes all labeled. Please complete A and B in your notes for the function listed above, and pause the video so that you have enough time to do this, and then resume the video to check your answers. So the answers are right here. Domain is x such that x cannot equal -3 because it's x plus 3 equals 0. You set the denominator equal to 0 is -3. The range is y such that y cannot equal 2 because you divide the coefficients, which gives you 2. The transformation would be y equals 2 plus -10 over x plus 3, because if you solve the division, you get a 2 with a remainder of -10, plug that into this formula, you get this.